Hello everyone, I'm Norman Wahlberger. I'm trying to formulate something of a mathematical framework for music, rather broadly, sort of covering many cultures and zooming out just from classical music or jazz or pop. And I'm also interested in developing some of the mathematical side of things that will be emerging from what we're doing. And I have also intimated that later on down the path, we're going to actually run into some really significant mathematical consequences of this sort of basic musing about music and the right way of thinking about it. So we've been talking about scales and modes. I want to go a little bit further today and talk about modes not just of the major scale, which is the usual, more familiar context, but also of the minor scale and more generally of more general scales. So we're thinking about the 12-tone clock sort of representation of our tones, the chromatic scale with notes 0, 1 up to 11. And then we've said that a scale is just a sequence of notes here, or tones, going around in the positive or clockwise direction, starting and ending at a particular tone. So for example, here is a major scale consisting of the tones 4, 6, 8, 9, 11, 1, 3, and 4, so that the initial and the final points are the same, and we call that particular initial and final point the tonic of the scale. Also associated to the scale, very important, is the interval sequence, which records the intervals between successive notes. In this case, 2, 2, 1, 2, 2, 2, and 1. And we recognize this important interval sequence. This is the sequence for a major scale. And it characterizes a major scale, and we say that this is a scale type. Okay, so we've already have some experience with the major scale setting and various modes for it, but today we want to go also to other scales. So let's talk about rotating an interval sequence, and let's be a little bit more formal than formally and introduce some notation for it, some terminology. So here is an interval sequence, say a general interval sequence, A1, A2, AK. So these are the successive intervals in some scale. And now we define this row or rotation operation, which does what? Well, it sends this interval sequence to this interval sequence, obtained by taking the first entry here and moving it to the last, and everything else gets shoved forward. So for example, if we apply this row to our major scale interval sequence, consisting of 2, 2, 1, 2, 2, 2, 1, then what happens is this 2 gets moved to the back, there it is there, and all the other ones get moved up. So now there's a 2, a 1, 2, 2, 2, 1, and the initial 2 got moved to the back. Okay, so that's the rotation of an interval sequence. And now we can also consider powers of this thing. Okay, in mathematics, we like to compose operations. That is, we want to do one and then followed by another. Okay, so this is called powers of row. So for example, row squared of I, where I is an interval sequence, one of these things, is by definition what you get when you take I, you apply row to it, and then you apply row to that. So for example, if we apply row squared to this initial sequence here, well, the first time we do row, we get this one, and then we do row once more. We have to take this thing and we move the 2 to the back. And then we just have 1, 2, 2, 2, 1, 2, and this 2 that's moved to the back. Okay? So this way we can talk about powers of row, which are bigger rotations of our interval sequences. Okay, so here's a quick review of what we already looked at in the context of modes of the major scale. So if we start with our major scale interval sequence, and let's call it I sub major, M-A-J for major. Okay, so if we take that particular interval sequence, then we can perform the rotation row and various powers of it. So we get other interval sequences. So the 0th power is when we apply row not at all. Then we just get the original sequence back again. If we perform a single row, then we get 2, 1, 2, 2, 2, 1, 2. That's associated with what we usually call the Dorian mode. Okay, but now we think about it as just what we get when we apply the first power of this rotation operator. And then the second one gives us 1, just applying rho to this one, we get 1, 2, 2, 2, 1, 2, 2. That's usually called the Phrygian, but we'll just consider it as rho squared. Then rho cubed is this one, the Lydian. Rho to the fourth is this one, Mixolydian. Rho to the fifth is this one, Aeolian. And rho to the sixth is this one, the Locrian. And then if we do one more to this one, move that one to the back, shift everything over, then we get back to where we started. So we see that rho to the 7 applied to this interval sequence is equal to rho to the 0. So that's sort of a cyclic rule here that tells us these powers of rho are not going to keep on being different. They're going to come back to where they started. Rho to the 7th of I major is equal to rho to the 0 of I major. Okay, so this gives us an alternate way of thinking about the usual modes of the major scale. So instead of thinking about the Greek names, Dorian, Mixolydian, etc., we can think a little bit more mathematically in terms of just which power of rho we are applying to the initial interval sequence that characterizes a major scale. So one more thing to observe here is that this particular one, the Aeolian mode, 2, 1, 2, 2, 1, 2, 2, which, say, in the key of C would correspond to the scale built up on A. So A, B, C, D, E, F, G, A. That is what's often considered a minor scale. And there are various minor scales, which adds some confusion to the story. Okay, so now let's go to the minor scale story, and we're going to choose the harmonic minor. Okay, that's the correct name. I often say melodic minor instead of harmonic minor. And its interval sequence is this one here, 2, 1, 2, 2, 1, 3, 1. So just to give you an example, here's our clock of 12 tones. And let's consider a scale, this S here, starting on 9, going 9, 11, 0, 2, 4, 5, 8, and 9. Now, to connect with sort of more familiar music, let's associate these tones with actual tones on an instrument. And so to free ourselves from the usual idea that middle C on the piano is sort of the center of the musical world, let's agree that in this case here, this 0 here corresponds to F. Okay, F. So that in the usual framework, if this is F, and this would be F sharp, this would be G, G sharp, A, B, A sharp, sorry, B, C, C sharp, D, D sharp, E, and F. All right? So in that case, this scale is what? Well, it starts over here, so that's number 9. What do we say that was? That was D, okay? So that was D, and then the next one would be E, and the next one, a single step to F, and then a 2-step to G, another 2-step to A, 1 step to B flat, and then a 3-step to D flat, and then D, okay? So that's the harmonic minor scale. So when we're going to be talking about minor scales from now on, I'm going to be talking about this minor scale. So that lessens the possibility of confusion, hopefully, with minor scales. All right, so now we can look at the modes of the minor scale. In exactly the same way as we did for the major, we take the interval sequence for our basic minor scale, say I mine for minor, and then we just look at powers of this rotation operator, which does always the same thing, takes the first one, moves it to the back, and slides everything forward. So there's row 1, you can look at it, row 2, row 3, row 4, row 5, row 6. And if you're on a piano or on a guitar, you can play these things out and see what they sound like. They're much less familiar than the major modes, but in principle, they're just as reasonable objects to consider. And again, we have the same cyclical rule that rho to the 7th of I min is same as rho 0 of I min, which is itself. Because, well, there's 7 elements in the interval sequence, and so that's what generates this 7-stage periodicity. All right, so you can kind of see now that there's nothing really special about major modes, or minor modes, in fact. We can play this same game for any scale. and it's intrinsically interesting. So what we end up is that we have relationships between various scales, which are modes of each other. So the landscape of scales becomes quite interesting because of this modal relationship between scales, very generally. Okay, so now it makes sense for us to enlarge our terminology and our notation to help us deal with modes in a more general fashion. So suppose that we have an arbitrary scale, a more general scale. Say this one here, so just I can be specific. Say 4, 5, 8, 10, 0, 1, 2, 4. So that's a scale starting and ending points are 4, and we're going around in the positive direction. Then associated with the scale, we know that we can associate two things, the tonic and the interval sequence. The tonic is the first note, which is 4, also the same as the last note. Let's call that T. And then the other important thing about this thing is the interval sequence, which in this case is 1, 3, 2, 2, 1, 1, 2. Okay, that's the interval sequence. Call it I, or I of S. So the scale is determined by this pair of data, the tonic and the interval sequence. So now we can talk about the kth mode of the interval sequence I. Okay, that's just going to be what we get when we apply this rotation operator rho to the kth power. Okay, that makes sense, right? So that what that is we're applying rho to rho to rho. We're applying k of these rows to whatever I we're starting with. And k is a natural number here. So in particular, it could be 0, 1, 2, 3, etc. Although we would expect that there's going to be a repetition that depends on the size of S. Now once we've defined the kth mode of the interval sequence, then we can also define the kth mode of the scale S. These are subtly different concepts. Okay, so what's the kth mode of S? S, as before, is associated to a tonic T and an interval sequence I. Well, we're going to define it this way, that rho k of S is going to be the new scale, which has the same tonic T. So it starts the same way that S does. But the interval sequence now is rotated k times. So we're taking rho to the k of I. All right, so this gives us a uniform way of talking about modes of a general scale. So two observations. One is simple but important. The zeroth mode of a scale is just the scale itself, because the zeroth mode corresponds to applying the operator rho to the 0, which is the identity operator. It doesn't change the interval sequence. Okay, so in the major case, the zeroth mode is what's called the Ionian mode. Okay, so that's the zeroth mode. Again, we're sort of preferring to start our count with 0 because it's mathematically nicer. Another somewhat more sophisticated idea is the following, that we can encode what kind of cyclical rule is associated to a general scale. The rule is that if we have a general scale S, that rho to the k plus size of S is equal to rho to the k. In other words, the repetition comes about when we add the size of the scale. So let me remind you that if you have a scale like this, okay, the size is 1, 2, 3, 4, 5, 6, 7. That's a scale that has size 7. There's 7 distinct notes in that scale. And that means that if we add 7 to any power of rho, then we get back to where we started. We get rho to the k again. So let's have a look at an example. So here's another scale. 4, 5, 8, 10, 0, 1, 2, 4. And it has interval sequence 1, 3, 2, 2, 1, 1, 2. And the tonic is 4. Okay, so let's apply some powers of rho to get modes of this scale. So the first mode is just rho of S. So what is that? Well, it's going to start on 4. And the new interval sequence is going to be the rotation of this interval sequence. And that means that this 1 has to move to the to the back and everything else moves forward. So the first interval here, we're just reading off, sort of starting from here, okay, is a 3. So from 4 to 7, that's 3. And then we have to add 2 to get 9, and then add 2 to get 11, add 1 to get 12, add 1 to get 1. I guess that 12 should be 0, shouldn't it? That's actually right. Let me just fix that. Okay, 12, okay, 0 is better. Yes. And there's another 12 over here, so let's put 0 there. Okay, so where were we? We've just added 1 to the 0 to get 1. And then we add 2 to get 3. And now we have to add 1 more because that 1 comes to the back for this new interval sequence, so we get 4. So this is the new scale, which is the first mode of this scale. The second mode, well, it's what you get when you rotate again. And another way of doing that right from here is to start with the same tonic, but now the interval sequence essentially starts from that guy there, 2. So 2, and then 2, and then 1, and then 1, and then 2, okay, and then another 1, and then a 3. So that's the second mode of the scale S. If we wanted the fifth mode, okay, so the first mode, the 0th mode, we start with this one. The first mode, we start with this one. Second mode, third mode, fourth mode, fifth mode. So the fifth mode is going to have an interval sequence that starts with this 1. Okay, so there's going to be a 1 there, and then a 2. Then we have to move to the front, and then a 1, and then a 3, and then a 2, and another 2, and then a 1. Now, it's just make sure that you understand this, that, I mean, this is at some level quite familiar to people with a mathematical background, but I understand that some viewers might be coming from the musical direction and their mathematics might be sort of shaky. But I want you to convince yourself that this relation of being a mode of a scale is kind of symmetrical. Okay, so say this last one here. Okay, this is a scale which is a mode of this scale here. Okay, it's actually the fifth mode of this scale. And I want you to convince yourself that conversely, this scale here is a mode of this one. That we could apply a suitable power of rho to this scale to get this one. Maybe you could figure out what power of rho you have to apply to this scale to get this scale. So what we're seeing here is this landscape of scales has some relations, some very tight relations, like family relations. Okay? These two scales are intimately connected, not just because they start on the same tonic, although that's certainly a common feature of them, but more subtly, they are modes of each other. So in the landscape of scales, then we start to see some mathematical structure because we can group scales together in terms of this modal relationship between them. So actually some non-trivial mathematics starts to emerge. And this is, I think, also quite interesting from a musical point of view because perhaps it enlarges your view as to the relationships of notes and scales and maybe encourages you to meander a little bit from the tried and true territory of major and minor. There's other scales around and we can play the same kind of game structure that we're doing here with these other scales too. I'm Norman Wahlberger. Thanks for listening.